So hello everyone, we are back again now with part 15 of the chapter Light, Reflection and Refraction. And in the previous video, we've discussed about refractive index, what exactly it is, and details about refractive index. So in this video, we'll discuss and we'll solve numerical based on refractive index. So let's go ahead and let's see where and what type of numerical we have in the textbook. So if you'll see page 176 of your in CRT textbook from the chapter Light, Reflection and Refraction, there are 5 questions which are based on the refractive indexes. So let's solve them one by one. Question 1 goes like this. It says a ray of light traveling in air enters obliquely. So if you remember, obliquely means it is bending. So light is entering like this. So this is normal. So it says a ray of light traveling in air obliquely, traveling in air enters. So this is our catchword here. It enters obliquely. It is entering here. And how did I understand that it is bending like this? Because it says it is traveling from, that it is entering from air to water. So this is basically air and this is water. Does the light ray bend towards normal or away from the normal? I guess I gave you the answer. So when light goes from air to water, it is actually moving from a rarer medium to denser medium. And we know when the light travels from rarer medium to denser medium, it bends towards the normal. And the reason is also because the speed changes. So rarer to denser, speed of light is changing, and that's why it is moving towards the normal. Let's see the answer also. The light ray bent towards the normal because the ray of light goes from rarer to denser medium. This is answer of question 1. Let's go for question 2. Now this is interesting, and this is, as I discussed and told you in the previous video also, where student make mistake is to understand what exactly is given in the question. So let's understand the question carefully. It says light enters. It means I have two medium. Light is entering from air to glass. It means light is entering from air to glass, and we know because it is denser medium, it will bend. Now the diagram is not needed for this numerical, but to understand the question, we have to understand this part, that light is entering from air to glass having refractive index. It means now this refractive index is given of which medium? As we have discussed in the previous video, refractive index is of the medium where light is entering. So light is entering from air to glass. So this is what is given in the question, refractive index of glass. Now I don't have to write NGA and 1 2 because this is absolute refractive index, which is given in the question. 1.50, no unit because it's a ratio of similar quantity. Question says what is the speed of light in glass? We have to find VG, and we have been given with something else, which is speed of light in vacuum. So I'll just write C, which is 3 into 10 raised to 8. Now this value we should know, even if it is not given in the question, you are requested and you're supposed to know the value. So if it's a 1 mark question, half mark will be devoted for the formula. So let's understand the formula. It's absolute refractive index, which means light is coming from air and going into glass. So the formula would be VA, or I'll say C, because we are talking in terms of vacuum, C upon VG. Now we have C, we have refractive index of glass, and we have to find VG, which is velocity of light in, or speed of light in glass. So this would be C upon NG. And now we know the respective values. So it is 3 into 10 raised to 8 and NG is 1.5. So basically 3 upon 1.5. So answer comes out to be 2 into 10 raised to 8 meter per second. So you can see here speed of light in glass is 2 into 10 raised to 8 meter per second, and that in vacuum it is 3 into 10 raised to 8 meter per second. So light is going from rarer to denser medium and it is bending. So let's also see the standard answer, which is available from the several different resources. You can see the answer is 2 into 10 raised to 8 meter per second. Let's go for the next question. Next question goes like this. If you remember this table, I told you based on the same table, we can have 4 mark question also, we can have 1 mark question also, 2 mark question also. So if you'll observe, it says find out from table 10.3, which is given here, medium having highest optical density. So if you remember, optical density has a relation with refractive index, and the relation is higher refractive index means higher optical density. I am writing OPD, optical density, which means, so if you observe amongst all of them, diamond has maximum refractive index, which means it will have higher optical density. And question also says find the medium with lowest optical density, which means lowest refractive index, which is air. So answer for highest refractive index is diamond, and answer for lowest refractive index is air. So I believe you have understood the question and the answer from the table itself. You have to just observe and understand. You can see diamond has the highest refractive index, so it's highest optical density, and air has lowest refractive index or low optical density. Another question, now question 4 is also based on the table, and there are three different materials given: kerosene, turpentine, and water. Let's highlight them. Kerosene, next is turpentine, and after that we have water, which is here. So if you'll observe, the numbers are 1.33, 1.44, 1.47. Question says, in which of these does the light travel fastest? So for this, we need to understand which is having higher refractive index, which means turpentine is having maximum density. It means light will travel slowest here and it will travel fastest in water. So out of these three, the correct answer would be, because refractive index is less amongst the given three of water, speed of light will be maximum in water and least will be in the turpentine out of the three. So you can see kerosene 44, 1.44, turpentine 1.47, water 1.33. So because water has the lowest refractive index, light travel fastest in this optically rarer medium than kerosene and turpentine. So turpentine and kerosene becomes denser and water becomes rarer in this situation. Let's go for the last question, which talks about refractive index of diamond is 2.42. What is the meaning of this statement? It means this bending is 2.42 times more than that in the air. So let's see the answer. By saying that refractive index of diamond is 2.42, we mean that speed of light in diamond is lower by a factor of 2.42 relative to that in the vacuum. So these were the numericals from the textbook on the concept of refractive index. And with this, we have completed the concept of refractive index, and in the next video, we'll talk about spherical lenses. So stay tuned, and I believe you're learning and you're enjoying also. That's it from my end. Thank you and have a great time. Bye-bye.